back. So now we learn about using table 6 to find critical values for confidence intervals. All right. So table 6 of appendix 2 gives various t values for different degrees of freedom df. We will use this table to find critical values Tc for a C confidence interval. In other words, we want to find Tc such that an area equal to C under the T distribution for a given number of degrees of freedom fall between negative Tc and positive Tc in the language of probability. So, what are we saying? We want to find Tc such that probability of negative Tc less than equal to T less than or equal to Tc is C. Okay. So, this is your student's T distribution. Mean is 0. You want area of C under the curve between these two endpoints, symmetric points, negative Tc to Tc. Okay. So we are going to look at our table, right? C is one of the column headings and degrees of freedom are the row headings. So C, that's the confidence level there. That is your C values and these are your DF values. Okay. To find TC for any specific C, we find the column headed by that C value and read down until we reach the row headed by the appropriate number of degrees of freedom. You will notice two other column headings, one tail area and two tail area. We'll use these later, but for the time being, just ignore them. Okay. So they are saying, for the time being, ignore these two parts. All right. We are simply looking at C and we are looking at DF. All right. If the degrees of freedom DF you need are not in the table, use the closest DF in the table that is smaller. Okay. The closest DF in the table that is smaller. This procedure results in a critical value Tc that is more conservative in the sense that it is larger. Okay. The resulting confidence interval will be longer and will have a probability that is slightly higher. Okay. So a conservative estimate means you need more area. You are okay to have more area inside than less. So if you have to increase Tc is slightly higher, you will get more area. So you would rather choose a Tc that is higher to have to be able to get more area inside. Okay. So in you when you look for this is why you are looking for degrees of freedom that is smaller. Okay. If you have a degree of freedom that is not in your table, then use the closest degree of freedom, degrees of freedom that is smaller. Okay. Let's look at an example. You want confidence interval 0.99, C for confidence level 0.99, sample size 5. If sample size is 5, degrees of freedom is 4 because degrees of freedom is n minus 1, 5 minus 1. So that is 4 here. C is 0.99. There you go. So you are looking at this particular number. Okay. You find the column with C equals 0.99. Compute degrees of freedom, that is n minus 1. Read down the column with heading C equals 0.99 until you reach the row headed by 4. The entry is 4.604. Therefore, the T of that C value is this. All right. Confidence intervals for mu when sigma is unknown. All right. Now here we in the section 7.1, I'm sorry, in the previous section 8.1, we found bounds positive, negative E on the margin of error for a C confidence level. We are using the same basic approach. E is, in the previous section we saw Z sub C, now it is T sub C. In the previous section we had sigma, now we have S. So T sub C, S over square root n. All right. So this is the maximal margin of error for a C confidence level when sigma is unknown. Okay. So the analog of the equation is, this is your negative E, that's your positive E. The margin of error should be like this, right? Mu x bar minus mu should be bounded by these two values, and that probability should be C. In other words, we have essentially found an approach to build the confidence interval. How do you find confidence interval for mu when sigma is unknown? Let x be a random variable appropriate to application. Obtain a simple random sample of size n of x values from which you compute the sample mean x bar and the sample standard deviation s. If you can assume that x has a normal distribution, sorry, x has a normal distribution or simply a mount-shaped symmetric distribution, then any sample size n will work. If you cannot assume this, then use a sample size of n greater or equals 30. Confidence interval for mu when sigma is unknown. That confidence interval is x bar, that is your x bar, minus E, x bar plus E. So mu between these two. That's your confidence interval. X bar is the sample mean of a simple random sample. E is TC S over square root n. C is confidence level. TC is the critical value for confidence level C, and degrees of freedom n minus 1. So this is where you need the table. Once you find TC, confidence level is given to you in your question. You can, using confidence level, you can find TC. TC S over square root n, that is your E. This is the maximal margin of error. You see, maximal margin of error. So it's also called error tolerance. And now x bar plus E and x bar minus E. These are the limits of your confidence interval. Okay, so here is an example. Suppose an archaeologist discovers 7 fossil skeletons. Reconstruction of the skeletons of these blah 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 shoulder heights in centimeters to be these 7 numbers 1, 2, 3, 4, 5, 6, 7. You know how to find the mean. Okay, so x bar, it should be x bar. X bar is approximately, well, how do you find mean? Add them all up, divide by 7. Okay. And then standard deviation. If you remember sample standard deviation, it is a bit of work, but You remember we learnt about this in one of our earlier chapters. Now, let mu be the mean shoulder height for this entire species of miniature horse. Assume that the population is approximately normal. Population of shoulder heights is approximately normal. Then find a 99% confidence interval for mu. All right. All right. Now you have to check for requirements. We assume that the shoulder heights of reconstructed skeletons form a random sample of shoulder heights for all miniature horses of the unknown species. Okay. We want to assume that we are told basically that the X distribution is approximately normal. Sigma is unknown, so we need to use student's T distribution and sample information to compute a confidence interval. N is 7. We had 7 samples. So degrees of freedom is n minus 1, 6. Confidence level is 0.999. Use your table to find TC for 0.999. 0.999. Degrees of freedom is 6. 0.999. Degrees of freedom is 6. 5.959. Okay. So, oh, I'm sorry. So that's incorrect. T is 0.99. Okay. So let's figure that out. 0.99 is here. Degrees of freedom is 6. So I get 3.707. There you go. All right. So with that, now you can find error tolerance or the maximal margin of error. Compute it. Now x bar minus E to x bar plus E. Okay. And that is your confidence interval. We will come to interpretation in our next video.